Welcome to the Chapter 4, Section 3 lesson video. We're going to talk about radical graphs today. So these are graphs of things like square roots or cube roots, and there's one other one we talk about as well, which is a horizontal parabola, which is kind of related to the square root graph. But yeah, these are going to be three new parent graphs, so let's go ahead and dive on in. So our goal for today is that we can graph radical functions, we can write transformation of radical functions, and we can graph parabolas with a horizontal axis of symmetry, meaning sideways parabolas. Okay, so let's talk about this first one first. So there's a couple different parts. We've seen some square root graphs before. Our square root graph kind of has four key features, all right? Our first two features are your basic ones. Whatever you are adding or subtracting directly next to your x variable is your left-right shift. And this is, as before, kind of an opposite type scenario. So a positive h will move you to the left, and a negative h will move you to the right. Then there is the k value on the end. This k value does our up-down shift. So a positive k value will move you up, and a negative k value will move you down. So those are pretty standard for a lot of our parent graphs. Now there's two other ones here. There's an a and a b value. Now we've seen a values before. A values, just like before, in the very front of our thing, outside of the radical, so on the very outside piece here. If we have a positive a value, then that means it's going to curve up. So a positive a means that it curves up, whatever direction it's going, and that'll make a little more sense in a second. Positive a causes us to curve up in some way. So these square root graphs are going to have a point and then a curve up. This would also be a curve up if it went that way. A negative a value, so a negative a value will cause us to curve down. Okay, so these are square root graphs are kind of like half of a sideways parabola when you look at them, but negative a value will cause you to curve down. Okay, b value, though, this is a little bit new. This number on the inside, so after you take out the common factor of x and h, okay, so take out the common factor of x and h, whatever the coefficient here that we pulled out of both of these, whatever its value is, will tell us whether the graph curves to the right or whether it curves to the left. So right for positive, left for negative. Good way to remember that. Positive numbers are to the right, negative numbers are to the left. Okay, so our kind of two examples of that are a positive b value would be either this graph or this graph, and a negative b value does the opposite. It goes to the left like that or like that. So these graphs are a little bit different. There's not arrows on both ends. There's a point on one side. That's one of the kind of key features here, is there's going to be a point on one side, and then it'll be an arrow going off forever. So here's our most basic one. Y equals square root of x. No a, no b, no left, right shift, no nothing down. This is going to have a critical point of 0, 0 in this case. So 0, 0 is our starting spot. There was no left, right shift. And then because both a and b are positive, it's going to be a half parabola going up and to the right. So positive, positive means up and to the right from that point. If you could find a y-intercept, go for it. If you want, it is not required. This is an optional one. Square or quadratic and cubic, and those were required. This one is kind of optional here. But yeah, that's our graph. It's just going to kind of be half of a sideways parabola. All right, couple examples real quick. We'll kind of breeze through these. Let's identify the key features first. This one, we are going to have a critical point of +3 means left 3, -2 means down 2, so that's our critical point. So we'll go ahead and draw our graph. We'll go left 3, so that's -3. We'll go down 2, that's -2. I'm going to go ahead and I'm going to plot a point right there. That's my critical point. So that's the point end of my graph. And I'm going to look in front. All right, in the very front is a positive, since there's nothing there. No common factor to pull out, so it's a positive as well. So from that point, I'm going to go up and right. So I'll just go up and right. You could try and find a y-intercept if you want. It's not required. Not all of these are going to have a y-intercept, so that's why we don't always bother. All right, now this next one, we're going to do a little bit of work first. So something I recognize is I see this negative in front right here, and there's no parentheses yet. So I'm going to pull that negative out as a common factor. So this gets rewritten as y equals, now when I say pull out, I don't mean of the square root, because we can't take a square root of a negative without it be like using I and stuff. So we're not going to pull it all the way out, we're just going to pull it in front of the parentheses like that. And then that plus 4 is going to stay on the outside. So I move that negative off the x. Okay, and I moved a negative off the 1, and I put it outside of a parentheses. That's going to tell me left or right direction. Okay, so let's go ahead. Our critical point, plus 1 means -1. So that's important because I pulled that negative off. It's now a plus 1, which means it's -1. Plus 4 means up 4. So there's my critical point. So we can go ahead and plot that. I'll go -1, 4. And plot that point. Oops, I used the wrong color, so I'll go ahead and I'll erase that, use the right color, plot that point. All right, and then since it is a negative on the inside, that controls my left-right direction. So the negative on the inside means I'm going to the left direction instead. So I'm going left direction rather than the right direction like I did on this last one. But in front is still positive, so I'm going to go left and up. So I will go left and up, just like that, left and up. Okay. All right, and then our very last one, we'll go ahead and we'll start this one off as well. I notice there's a number in front of the x on the inside, so I'm going to go ahead and pull that off as a common factor. So anytime there's a number in front of the x or a negative in front of the x, we're going to pull it off. So like this, I'll pull the 2 out. X plus 4. This is kind of important because it does change what my left-right shift is. It used to kind of look like it was a plus 8, but now it looks like it's a plus 4. So my critical point, all right, so that plus 4 means I'm going to go left 4 for my shift. No up-down shift, so left 4, up 0. So that's my critical point. So I'll go ahead and draw my graph. I'll go -4, up 0. So I can go ahead and put my critical point right there. And then I pay attention. I look on the outside. Oh, there's a negative on the outside. So that means I'm going in the down direction. But that 2 on the inside is positive. So that means I'm going down and to the right. So down and to the right. And there's our graph. Awesome. Okay, so these are our 3 examples of a square root graph. Okay, so that's a square root. Up next, let's talk a cube root graph. So a cube root graph is a little bit different. And there's a reason why this cube root graph is a little bit different, and I'll make a little note of this off to the side. The cubed root of a negative, or let's just say a -1, is -1. I can take the cube root of a negative. When we, like on that previous one, the reason that negative could have gotten stuck on the inside and change our left-right direction is because the square root of a negative is the imaginary number I, which we're not going to worry about in these graphs. So since I can cube root a negative, we only have to worry about an a value on the outside. If you get a negative or something on the inside, you can pull it to the outside and make the outside negative instead. Okay? So just like before, this h value, it controls a left and right shift. This k value, it controls an up and down shift. And then this a value, it controls whether our graph is increasing or decreasing. And what I mean by that is kind of like a square root was half of a sideways parabola, a cube root is going to be a sideways cubic. So by increasing, I mean it's going to look like a cubic on its side but going uphill, and decreasing would be looking like a cubic on its side but going downhill. So it's kind of like you turn your head sideways, draw a cubic, and then when you look back, increasing goes uphill, decreasing goes downhill for that graph. Okay, so here's our most basic graph over here. Critical point starts at 0, 0. It's our HK values. There's none here, so it's 0, 0. And then this one, since there's a positive in front, it's increasing parabola, sideways parabola on the right, decreasing sideways parabola on the left. So it's increasing as we go from left to right to make that cubic graph. Okay. Let's go ahead and try a couple right here. So this first one that I see here, nothing really crazy difficult to do. There's no negative or anything, no common factor to pull to the outside. So let's just identify our critical point right off the bat. So our critical point for this one, let's see, +1 means I go left 1, -6 means I go down 6. Okay, so I'm going to go left 1 and down 6. So that's -1, negative 6. And that's where my initial point is going to go. So that's my first point. And then since it is a positive on the outside here, there's no number we pulled out and there's nothing there, so we assume it's positive, I'm going to draw an increasing graph. What that means is as I go to the right, I will draw a sideways parabola increasing, and on the other side I'll do the opposite to kind of make it look like a sideways cubic. But as that whole graph goes along, it's always increasing. It might flatten out a little bit, but it's increasing. Okay, now this next one, there is a little we can rewrite. Since I have a negative x on the inside, I can take that negative out of the cube root and put it in front. So I'm going to rewrite this as y equals negative cube root of x and then plus 4. Okay, all this means is that rather than increasing, this one will be a decreasing one. So our critical point, there is no left-right shift. There's nothing on the inside there, and then a plus 4 on the end. So we'll go out 0, up 4. So we'll draw a little graph. We go up 4. Nothing left or right, so I'll put my first point right there. And then because I had that negative in front, I'm going to draw it as a decreasing graph. So I'll draw a sideways parabola going to the right, a sideways parabola going to the left, and it's decreasing along that whole way. It does get a little tricky to draw these, and mine are okay. They're not fantastic. If you really need to, you can kind of turn your head to the side and draw these as parabolas, because that's probably what your brain's more used to. But when you look back, this should be kind of like a cubic on its side decreasing. Okay, we have one last parent graph to talk about for today. Our last parent graph to talk about today is a horizontal parabola. Now, take a second and look at this equation because it is very different than before. Okay, a couple things should jump out at you, right? It kind of feels like opposite day, right? Instead of a y, this says x equals. That's still in its normal spot, but then it says y minus k on the inside. So notice k, that's our up-down shift, right? That's our up-down shift. So it's going to be the one that's opposite and on the inside here. And then plus h. So this is our left-right shift, and it's not going to be opposite. So positive means right, and negative means left. This is essentially backwards day. Everything is switched. The x's and the y's are switched. That's how you tell it's one of these horizontal parabolas, is it's x equals. That doesn't really switch, that's fine. But then the y is where the x usually is. The k, the up-down shift, is on the inside this time, and you know that it's going to do that because this is an x equals, not a y equals. That's your giveaway. So that when you see x equals, you're like, oh shoot, okay, so this is up, down, and opposite, and this is left, right, and not opposite. So let me label that a little bit just to help it make sense. So inside, this does our up, down shifts. So a positive k is going to move the whole graph down, and a negative k is going to move the whole graph up, right? It's the opposite of where it normally is. That's normally where left, right is, but now it's up, down, and up, down is opposite. H, it does our left, right shift, and normally it's opposite, but it's not this time. So positive h moves us to the right here, and negative h moves us to the left. Now, the way you know it's opposite day, the way you know that this is one of these kind of opposite problems, is because you look over here and you see it says x equals, not y equals. That's your clue. That's your giveaway. So when you graph these, you look at your shift, you look at these, right? You see it's an x equals, you figure out what your shift is, where your critical point is, and then you're going to plug in 0, and rather than plugging in 0 to get your y-intercept, right? Plugging in your 0 here gives you your x-intercept. Man, mind blown. Everything is opposite. Everything is different than before, right? We're plugging in 0 to get the x-intercept where it crosses the x-axis, not where it crosses the y-axis this time. Okay, so my little example picture right here, it's a sideways parabola, nothing crazy, right? There's no up-down shift on the inside. There's no left-right shift on the end. So it's at 0, 0. And then we draw our sideways parabola. All right, let's go ahead and try a couple examples. Okay, so here's our giveaway. The way we know it's a sideways parabola is because it says x equals, and then it's a y squared. That's the giveaway. That's how we know it's kind of opposite. So when we start this problem, we just have to kind of like retrain our brain to think about what we're looking for. So our vertex here, right? So inside the parentheses, we're thinking opposite. This is normally our left, right. So opposite world, that's going to be our up, down. That's our y value. So +1, and it's opposite, so it's -1. That's weird. Okay, then this is our left right, and it's not opposite because it's on the outside, so that's going to be minus 2. So that's where my vertex is, minus 2, minus 1. And then we got to plug in 0. So we plug in 0, so 0 plus 1 squared minus 2. That's 1 squared minus 2. 1 minus 2 is negative 1. Now, this is not our y-intercept when we plug in 0. Since it's sideways, this is our x-intercept. Man, right? That's like mind blown. It feels kind of different. So we draw our graph. Okay, our first point is going to be at negative 2, negative 1. Right, we can go ahead and put our first point here. This is our vertex for our sideways parabola. Okay, our a value in front is positive, so we know it's going to go to the right. I kind of think I forgot to say that on the slide. So the value in front determines positive right versus negative left. And then we know our x-intercept, right? Our x-intercept right here is negative 1. So we could go ahead and we can put a mark right here at negative 1. So we know that our sideways parabola is going to go up like that and down like that. Notice I don't worry about the y-intercept. That's not important here. I'm worrying about the x-intercept because it's opposite, right? It's opposite world, sideways parabola. Everything is kind of backwards. Okay, let's try that again. So we'll do the vertex thing again. So we say, all right, so vertex, I look at the problem, I see x equals a y squared. I know it's an opposite day, right? I'm thinking opposite, opposite, opposite. So inside, let's see, nothing inside. So inside is normally our left, right, but that means it's actually our up, down. So our y value is 0. And then we look at on the outside. This is our left, right now. So since it's minus 4, that means I'm going to go left 4. So when it's on the outside, we don't do the opposite thing. So negative 4, comma 0, that's my vertex. To get my intercept, I'm going to plug in 0. So I go negative 0 squared minus 4. Okay, negative 0 squared, so that's negative 0, 0 times 0 is 0, still 0, minus 4 is negative 4. Okay, so my x-intercept is negative 4. Well, that's also my vertex. Okay, so my vertex is on my x-intercept. So let's go ahead and see kind of what this graph is going to look like. All right, so we'll go left 4 to negative 4. This is going to be our first point. This is where our vertex is, negative 4, up and down 0. That's also our x-intercept, so we don't get a lot to go with here. Now, we're going to have to look back at our equation for our extra clues here. Let's see. Because I see this negative in front, I know that it's going to open up to the left. So I'll go ahead and I'll draw a sideways parabola opening up to the left rather than the right. And there we go. That's our graph. Okay, so we learned 3 new parent graphs. We learned the square root parent graph, we learned the cubic parent graph, and then we learned this kind of opposite day style sideways parabola parent graph. All right, you should be able to get started on the homework. I'd encourage you to give it a try. If you have any questions, please reach out. Otherwise, I'll see you in our next live session.